The next time it rains, stop for a moment, hold out your hand. Feel that drop of water land on your skin. That single raindrop has traveled farther than you might imagine. It has been an ocean. It has been a cloud. It has been ice on a mountaintop and vapor in the atmosphere. It has been part of a river, a lake, a glacier, and a thunderstorm. And here is the part that should genuinely amaze you. That same water has been cycling through Earth's systems for over 4 billion years. The raindrop on your hand might contain water molecules that once fell on ancient forests, flowed through prehistoric rivers, or evaporated from oceans that existed before complex life on Earth began. Water doesn't appear when it rains. It returns. For most of human history, rain was a mystery wrapped in mythology. Ancient cultures built entire religions around it. It was a gift from gods, a punishment from the heavens, a force beyond understanding. Then science looked at the sky and asked the simplest possible question: where does rain actually come from? The answer turned out to be one of the most elegant systems in nature, a continuous loop of evaporation, condensation, and precipitation that has been running without interruption since Earth's oceans first formed. Scientists call it the water cycle. And once you understand how it works, you will never look at a rain shower the same way again. Let's follow a single water molecule through the full journey, step by step. Step 1. Evaporation. It starts at the surface. Oceans, lakes, rivers, and even puddles on the street are constantly losing water molecules to the atmosphere. When sunlight hits a body of water, it transfers energy to the water molecules near the surface. Some of those molecules absorb enough energy to break free from the liquid and rise into the air as water vapor, an invisible gas. This process is called evaporation, and it is happening constantly. Everywhere there is liquid water on Earth's surface. The oceans alone evaporate roughly 502,000 cubic kilometers of water every single year, an amount almost impossible to visualize. Step 2. Transpiration. The oceans aren't the only source. Plants contribute massively to the water in our atmosphere through a process called transpiration. As plants absorb water through their roots and use sunlight to convert carbon dioxide into energy, they release water vapor through tiny pores in their leaves, called stomata. A single large tree can release hundreds of liters of water into the atmosphere every day. Multiply that across the world's forests, and you have a significant second engine driving water into the sky. Scientists sometimes combine these two processes into a single term, evapotranspiration. Together, they are the primary mechanism moving water from Earth's surface into the atmosphere. Step 3. Condensation. Once water vapor rises into the atmosphere, it begins to cool. And as it cools, something happens. The vapor transforms back into liquid water droplets. But water vapor doesn't condense on its own. It needs something to condense around, a tiny particle of dust, pollen, sea salt, or smoke. These particles are called condensation nuclei. Without them, water vapor would remain as gas, even when conditions favored liquid formation. With them, water droplets form around each particle. Billions of these microscopic droplets, each one nearly weightless, cluster together. That cluster is a cloud. Step 4. Precipitation. A cloud is not simply water floating in the air. It is billions of microscopic water droplets suspended by rising air currents. As more water vapor condenses and the droplets grow larger and heavier, the rising air currents can no longer support them. The droplets begin to merge, colliding with each other, combining, growing. When they become heavy enough, gravity wins. They fall. Rain, snow, sleet, hail. The form depends on the temperature conditions in the cloud and between the cloud and the ground. But all of it is the same water, returning to Earth's surface after its journey through the atmosphere. Here's where the water cycle gets genuinely profound. The total amount of water on Earth is essentially fixed. It does not increase or decrease in any significant way. The water we have today is the same water Earth has always had, cycling endlessly through oceans, atmosphere, ice caps, rivers, underground aquifers, and living organisms. Scientists estimate that Earth holds about 1.386 billion cubic kilometers of water in total. Of that, about 97% is salt water in the oceans. Less than 3% is fresh water, and most of that is locked in glaciers and ice caps. Less than 1% of Earth's total water is accessible freshwater in lakes, rivers, and underground sources. This makes the water cycle not just a natural wonder, but the mechanism that keeps that tiny fraction of accessible fresh water continuously moving, cleaning itself and redistributing across the planet. Precipitation falls. Some of it flows over land as runoff, collecting in rivers and lakes. Some soaks into the ground, becoming groundwater, stored in underground aquifers that can hold water for thousands of years before it returns to the surface. Some falls as snow in mountain ranges, stored as glacial ice that slowly melts and feeds rivers through the warmer months. And then evaporation begins the cycle again. But here is the twist that makes the water cycle even more extraordinary. Some of the water falling on Earth today is not from Earth originally. Scientists believe a significant portion of Earth's water was delivered from space, carried by comets and asteroids in the early solar system billions of years ago, during a period known as the Late Heavy Bombardment. These icy bodies, forming in the outer solar system where temperatures were cold enough to freeze water, collided with early Earth and deposited their water here. In other words, the water in that raindrop on your hand may have started its journey not on Earth, but in the outer solar system, on a comet, traveling toward a young planet still forming its oceans. And water doesn't only fall here. Scientists have found evidence of water ice on the Moon, on Mars, in the atmospheres of gas giants, and even in molecular clouds in deep space. Water is one of the most common molecules in the universe. What we have on Earth is just one small, endlessly recycled reservoir of something that exists across the cosmos. So here is what you are actually looking at when it rains. Every raindrop is ancient water, water that has cycled through Earth's systems for billions of years, water that has been ocean and cloud and glacier and river and living organism, over and over and over again. The water in your body right now has been part of that cycle countless times. It was ocean water millions of years ago. It fell as rain on prehistoric landscapes. It flowed through rivers that no longer exist. It was breathed out by animals that have been extinct for tens of millions of years. And when it leaves your body, through breath, through sweat, through the natural processes of life, it will return to the cycle again, rising into the atmosphere, becoming a cloud, falling as rain, somewhere, sometime. Again, here's the thought that should stay with you. The water cycle is not just a science lesson. It is one of the most remarkable systems on any planet we have ever studied. A closed loop of continuous motion that has kept liquid water, the foundation of all life we know, cycling across this planet for billions of years without stopping. Every drop of rain is not new water. It is ancient water, temporarily visiting the sky before returning to the Earth it has always belonged to. The next time it rains, hold out your hand again. And remember, what just landed on your skin has been an ocean, a cloud, a river, a living creature, and a raindrop more times than you could ever count. Water doesn't fall from the sky. It comes home.